Okay, now that we have R set up and we want to work with some lidar here, we're going to pull in our raw lidar files, which I actually have saved in a separate folder, actually into a portable hard drive here, which is an H drive now on this computer. So I'm going to need to change this to H. And this is what it is telling me my last directory. That's where my last files are. If I want to look what's in there, I can do list files, last directory. Boom, that's a lot of files. Now, I have already kind of pinpointed some ones that I'd want to work on, like 4 that I knew from looking at Google Maps, or Google Earth rather, like where my successional farm was, or the successional forest rather was, and so I kind of already pinpointed this. And so I already knew from looking on Google Maps that I needed these specific files. So what this syntax is, this is a little complicated, but it's looking for these patterns of these specific coordinates. Like, see how the files have a coordinate in them. I think that tells you the southwest or southeast corner. I'm not really sure, but we could look it up in the neon stuff. But each one of these has for each collection or each little tile, has the actual LAS file that we're going to be working with. But it also has a lot of GIS data with it too, like some shape files, KMLs, projection stuff, like all kinds of database stuff that you could work with if you were working with this in like QGIS or ArcGIS or anything. But what I've done is I made this list files. So this is telling me the file. This is going to create a list of the correct file names that we will need to work with. And so I've, like I said, I've already kind of matched it in here, and it's just looking for a pattern is what it does. So it's like looking for this pattern here or this pattern, and then the asterisk is a wild card thing, meaning like it's really just kind of isolating that pattern, looking for it. Let's run it, see does it work. Boom, we should have 4 files. There we are, 4 file names. That's great. So the bulk of what you need to work with, because like I said, you're not going to be necessarily working with these huge amounts of, where you're going to have to pull from hundreds of data or whatnot, is you have this core function, which is the read last function inside the package lidar. So this, where it says lidar : this is kind of like a thing that you see some programmers do. It's just, pulling the package and then the function in it. We've already loaded this package, so we don't need to do this. So we can erase this. And what this will do is this is going to read in our last file. It takes a second. Now, lidar files tend to be pretty large. We look at this file by itself. We can just type it in here. We can see that it's about 512 megabytes, which is not nothing, right? Like that's manageable. But we're going to pull in all 4 of these, and together that's going to be upwards of 2 gigabyte. And sometimes when you're working in R, if we were to try to mosaic these and stitch these together, that's going to kind of take up a lot of memory space very quickly. So the computer that I work on tends to be like a GIS more focused workstation, so it has about 64 gigabytes of memory. So you may need to be aware of that depending on what you're working on, like whether your laptop can necessarily handle it or not. But you can get around that. So what the rest of this code does is we're going to work on one last file, and then we're going to go to the one that we already have pre-done. The first step we need to really work with this is we need to do what's called normalizing the height. Normalizing the height, what that does is if we were to look at, let's do a histogram real quick so we can show the distribution of our LAS data. So interesting structure to LAS files. They're really cool, but they're kind of complicated. So like in R, they have think of it as like 2 tiers, right? So we type in our object first, then LAS, and then we use the @ sign, and that lets us get to some of the information about this. So we want to look at the raw data. So we do data, and then we use our $sign for the columns, and then we see actually the columns that are in the lidar file. So we have the X and Y position. That's basically the ground coordinates of it. Then we have Z, which is our height, which is in meters. And then you have the GPS time, so time that it's collected. And then you just have some additional information, LiDAR-based information, such as the intensity, the return, the number of the return, the total number of returns in their scan directions, a lot of diagnostic information. Classification is really cool we're going to work with. That basically tells you if it's, in some cases, a ground point, or if it was something reflected off water. Some of the really good data will even tell you if it's vegetation or noise or a building. But we want to look at the heights. So we're going to look at Z. And so we're going to histogram of that. And so we can see there's no zeros in here. The reason is that LAS file, that raw LiDAR file, is elevation from a datum, and the datum being sea level. So it's giving you elevation. Now what we want to do is we want to make it relative to a 0 so that we can work with everything on the ground. So normalize height, what it's going to do is it's going to use an algorithm in here that kind of flattens everything out. It's called the 10 algorithm, or triangular irregular network. So basically it's kind of matching points with geometry, and then it's going to lower everything down so that our ground points are going to be 0. So we're just flattening everything. This little code tells it to, this is the NA, meaning if there's like blank values or whatever, to remove them. Yeah, true, definitely want to do that. And our resolution is going to be 1 meter. So we're going to run that. And it's going to take a second. So what it's doing is going through all those points and it's adjusting it. So if it's a ground point, what it's going to do is it's going to pull that ground point down to 0. If it's not a ground point, it's going to adjust it relative to the ground points now. So when we wait for it, because it's LiDAR, it takes a minute to run. All right, so it's running through this rasterization process. This is where you can get up and get tea or coffee or whatever if you want to. The next step of what we're going to do here, I'll tell you this while it's running, is the filter point of interest. So what this is going to do is we've isolated within what we call our LAS norm here. Let's run our histogram on our LAS norm and see what that looks like. Error must be numeric. Oh yeah, because I'm dumb. It's got the same structure as the other one, right? So what we got to do, norm, data, NZ. Boom. We have a little bit, it looks like we got some errant points there. So what we want to do is we want to do this filtering method. That's going to filter out any of the noise here. Now let's do the same thing. Now we got data. So we can see it starts at 0 and we got a nice distribution that looks like a forest. It goes up to about 40 meters. So that one's kind of ready to do. Now we're going to skip to the already mosaic version of this, because what the rest of this code does is does it for a second tile, then a third tile, then a fourth tile, and then binds them all together and then writes that file out. But we already have that done. So this is the step where we've moved from our raw LiDAR file up to a normalized file. In the next video, we're going to go through and make some working data with that.